All right. Hey, everyone. We're going to do 2.3 today. Let's jump right in there. So for 2.3, we're talking about linear inequalities. So these are different from linear equations, and we're going to be using symbols of inequality. So you all know less than, greater than, less than or equal to, greater than or equal to. And so these are going to be in place of the equal sign. And so we're going to solve linear equations symbolically and apply those same properties that we've already been looking at with equations. So let's check them out and review them. Adding and subtracting both sides of the inequality doesn't change the inequality. So we're going to be still moving from left to right through addition and subtraction. However, multiplying and dividing by a positive number, of course, doesn't change it. But if you do a negative number, then that does flip the sign. This key is the most important piece of information when we are working with inequalities. Anytime you multiply or divide both sides of an inequality by the same negative number, you have to flip the inequality symbol. Okay, so let's do. Here's some examples over here. Let's look at the blue one first. 2 is less than 5. We agree. If you multiply both sides by 3, then we get 6 is less than 15. That is still true. Well, if we have 2 is less than 5, which we agree, and we multiply both sides by -3, then we end up with -6 and -15. Well, -6 is actually larger than -15. So you can see that the symbol flips when we're dealing with negatives. So that is going to be very, very important in consideration for actually solving inequalities. And so let's go through A at the bottom. X plus 3 is less than -6. The way we solve for X is just get rid of that 3 and we're going to subtract 3 from both sides. Okay, doing that, we get X is less than -9. Notice nothing changed with our symbol. We just added and subtracted, no big deal. All right, B, we're going to be dividing by 3 to solve for X. And so that's a +3. So again, nothing changes with our symbol. We have X is less than or equal to 7. So that means any number less than or equal to 7 would make this inequality true. Okay, that's what this means. This is a range of numbers. Any number that is in this range could be substituted in for X, and this still would be true. Pause and think about that for a second. Think about what these inequalities that we end up with mean. For C, we're going to be dividing by -3. Whoa, red flag. We're going to be flipping the sign because we're dividing by a negative. So we're going to have X is greater than or equal to -8. So any number bigger than or equal to -8 will make this equation true if it's larger than or equal to -8. Okay, so that is that. I would say always to check your work. And so by doing that, you just pick any number that's bigger than -8. Let's say 0. So put in a 0. -3 times 0 is 0. Is that less than 24? Yep. Well, let's say if we put something in that's smaller than -8, let's say -9. So -9 and -3 is +27. Is that less than or equal to 24? No. So you can see that anything less than -8 would not work. That's what we mean by solution to the inequality. All right, so now we're going to do some examples. Solve the inequalities symbolically. Write the solution set of the interval notation. This is where section 1.3 comes into play. So that is why that was really important for us to cover first. So again, this is a 2-step equation. So this is Mr. X's wife, his girlfriend, boom, boom. We can still do the same kind of thing. The only key here is that if we multiply or divide by a negative in the end, we flip the sign. Oh, adding, there's a +4, so we need to subtract 4 from both sides. And that gives us -5x is less than or equal to -15. Divide by -5, woo, 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 red flag. I don't know what I just did or why I did it, but that was a red flag, okay? So anyway, red flag, we need to flip our sign. So therefore we get x is greater than or equal to 3. And why did we do that again? Because we divided by a negative. Okay, so now what happens when we have variables on both sides of our inequality? The first thing we do is just like if it was an equation, we put all the x's on one side and all the constants on the other side. Uh-oh. I'm doing the most with this, okay? Oh, I skipped interval notation. Let's go back to part A. It says all numbers greater than or equal to 3. That means or equal to, we're going to put a hard bracket at 3 and say all the numbers bigger than it. When we have inequality notation, it's really simple to do interval notation because we can use this symbol to help us draw our arrow. And that tells us which direction we're going. Remember, infinity is always to the right and negative infinity is always on the left. Now let's go on to part B. Part B says, move that x to the other side by subtracting. And we end up with 2x minus 2 is greater than negative 5. And then we move that 2 to the other side. So add 2 to both sides. And we get 2x is greater than negative 3. Finally, we want x by itself, so we'll divide by 2. Because we're dividing by a positive number, we don't change anything. X is equal to negative 3 over 2. Writing this in interval notation, maybe drawing that number line first would help. Numbers bigger than, but not equal to, negative 3 over 2, which is really just negative 1.5 if you think about it. That is going to be our interval notation. Example 2. Now we have a fraction. I would say anytime you have fractions, get rid of it by multiplying. So let's see if that's what the textbook does as well. Yes, we're multiplying everything by negative 5. And so we do it to the left and to the right. So negative 5 times both of these quantities and negative 5 times this entire fraction. The cool thing is that when we do the fraction will actually cancel, reduce to 1. Here we go. Because we are multiplying by a negative, we do have to reverse the sign. Notice that there was a sign change here. Because we're multiplying everything by negative 5, we're reversing that symbol. Okay. Those negative 5s cancel and voila, we're left with just 2 minus x. On the right, we did scale everything by negative 5, so we end up with 10x minus 5. And so now we have a simple situation and we can solve it. So let's think about that one more time. Let me take a couple steps back and talk about this one real quick. There's a negative 5 in the denominator, and the best way to get rid of it is to multiply everything by negative 5. But in inequalities, if you multiply by a negative, you have to flip the sign. So what we end up with is we end up seeing the sign flip and everything multiplied by negative 5. Noticing that those negative 5s cancel on the right and they scale on the left, we end up with this equation or inequality. So then we can have all the x's on this one side. So add x to both sides. And then you're going to add 5 to both sides. 11x is greater than or equal to 7. X is not by itself just yet, so you need to divide by 11. That's not a negative, so we don't switch our sign or anything. We get x is greater than or equal to 7 over 11. Write your number line, 7 over 11, inclusive, arrow to the right. That means we're going 7, 11 inclusive all the way to positive infinity. Soft bracket on positive infinity because you never actually get there. All right, part D, we have some simplification that we need to work through before we actually do the problem. So we're going to use distributive property, and we're going to distribute this negative 2 and get this. Distribute this negative 2 and get this. Then we're going to combine like terms where this 8 and this positive 4 become a positive 12. And that is going to allow us to then move forward with putting all of our x's on one side. So let's add 2x to the other side and add 4 to the other side. Divide by 8, x is less than 2. And this one is an arrow to the left with the 2, not inclusive because it is not less than or equal to. So that's going to be negative infinity to 2. Again, because negative infinity is on the left, positive infinity is on the right. A compound inequality occurs when two inequalities are connected by the word and or. So when we have and, that ends up being numbers between two numbers. So if x is less than 70 and greater than 40, then that means it's between 40 and 70. So let's look at some examples of this. We may have a two-part inequality, and so we're working from the inside out. First thing we want to do is add 1 to all the sides. Notice I say all the sides because we're going to do it to the middle, the left, and the right. Okay. So that leaves us with 5x in the middle, -5 and 15 as our extremities or lower bounds. Last thing is to divide by 5. We're not dividing by a negative, so we don't flip no symbols. And we have x is between -1 and 3. And it's greater than or equal to -1. So that's going to be a hard bracket and a soft bracket on 3. So there we have it. Interval notation, x is between -1 and 3. All right, so for part B, we got fractions again. Whoop-de-doo, yay. Fractions 8 and 4 are our denominators, so we're going to multiply by 8 because 4 and 8 both go into 8, okay? So when we multiply everything by 8, this first number, these 8s are going to cancel, and we'll just be left with 3. The second one, the 8 and the 4 will cancel, but that will leave a power of 2 at the top, not a power, but a multiple of 2 at the top. And then 8 times 1 is just 8. So let's see what that is. We end up with just 3. 2 times 3 minus t, and then just 8. Okay. The distributive property here says 6 minus 2t. And now, now we can just solve. Subtract 6 from both sides, all sides. And then we're going to be dividing by -2. So that means our signs are going to flip. Notice that the signs flipped because we divided by negative. So now we write our inequality, but it looks backwards to me because the biggest number is now on the left and the lower number is on the right. So we could actually rewrite this so that it makes sense to us. Put -1 where it goes, put the 3 over 2 where it goes, and it's the numbers in between those. If it helps you, you may want to write this like -1 is less than t, which is less than 3 over 2. I really literally just wrote this in reverse order, so it can help me make sense of the number line. Pause that and try that one again to see if you really understand. All right. Example 4, complete the following. Graph y equals x plus 3 and y equals 4x. Well, that's can be done in the calculator. Once you graph both of these lines, then what happens is they have an intersection. That intersection is at 1, 4. But that's how you graph them. Okay. It says, for what value of x do these things equal each other? Well, the value of x is 1, the value of y is 4. So the value of x equals 1 is going to be our answer there. It says that x equals 2 is the graph y equals x plus 3 greater than or less than 4x? So if x equals 2, that's right here and right here. Which one is greater? The higher one, this is 8 and this is 5. So I would say 8 is greater than 5. So that means this line, this green line, 4x is greater than x plus 3. So, yes. So x plus 3 is actually less than 4x, or you could say this 4x is actually greater than 3. I mean x plus 3. Either way is correct. Okay. So now let's solve the inequality. It's basically saying, where is this less than or equal to 4x? Where's the blue line less than or equal to the green line? From here, it's equal, and all the way out, it's going to be less than because the green line is above it. The blue line is below. So from x equal 1 to infinity, the blue line is going to be underneath the green line. So you find a point of intersection, and you say, hey, the blue is below the green from this point on. So that is x is equal to or greater than or equal to 1. Interval notation from 1 to infinity. Example 6. We're going to use this graph, and this is that hypothetical situation to write interval notations, okay? So ax plus b equals 0. So where is this line equal to 0? Right here. It's the y equals 0 line is right here. So where does that cross? 1, 2, 3, 4. So that'd be x equals 4 because this point is 4, 0. Okay, so it's saying where is this line equal to 0? And the reason why we say that is because this is 0, 2, 4, 6, 8, 10, -2, -4, -6, -8, -10. So that is usually it'd be y equals this. So it's basically saying when is y equal to 0? Right here, x equal 4. Oh, my bad. It's 2, 4, 6, 8. My bad. That's 8. Y equal 8 because it's 2, 4, 6, 8. I'm sorry, I forgot to recount by twos. Now it says, when is the graph less than 0? So that'll be all down here. Everything down here is less than 0. So from 8 all the way back is less than 0. So we're going to say where it's below the x-axis, that is from negative infinity to 8. Where is it above? From 8 on. And we're going to say interval notation because it says greater than or equal to. We're actually going to include the 8 in this set. And that's why you have the hard bracket. Stop that and rewind it and make that make sense to you. All right, two graphs f and g are shown. Complete the table. Solve the equation. G of x is equal to f of x. Where do these lines have the same y value? Right where they intersect. And that is 3, 2. I'm sorry, you do the x value first. 2, 3. So these lines equal each other when x equals 2. And then the next question says, Solve the inequality for when G is above f of x. Well, G is above f of x. All of this. You see how G is on top, like green is on top of blue? So G is above f of x from 2 backwards. So I would say from negative infinity to 2. You don't include 2 because at 2, they are not greater than or less than, they actually equal each other. All right, so this is from a calculator screen. It says assume y1 represents a linear function. Use the table to solve the inequality. Solve the inequality. Write the solution set for the inequality. Where is y1 greater than 0? So all of these numbers are greater than 0. And that's when x is literally below 1.8 because it becomes equal to 0 at 1.8. So anything below 1.8. So it's when x is less than 1.8 or negative infinity to 1.8. Let's see what the textbook has to say. You see where y equals 0? That's when x is 1.8. So y is greater than 0 right there. Interval notation from negative infinity to 1.8. From negative infinity all the way till you get to 1.8, but we're not including 1.8 because it's actually equal to 0. It says, when is it equal to 0 or less than? So it would be equal to 0 here and less than 0 all the way continuing down. So that'd be to positive infinity. 1.8 to positive infinity. Like that. Okay, moving on. Example 9, application problem, yay. Okay, cars F and G are traveling in the same direction. Their distances in miles north of Leander are after X hours is computed by the function f of X and G of X respectively. The graphs for the first 3 hours are shown below. So we got 1, 2, 3 hours. They're not comparing their distance to each other. They're comparing their distances north of Leander. So car F was north of Leander about 20 miles. After an hour, it was about, 80? 2 hours, they're about 140, and then 3 hours is just off the chart. Whereas graph G starts off farther away, ends up being in the same spot after an hour, and then after 2 hours, it's 120. So it's driving slower. It says, which car is faster? How do you know? Well, I would say that graph F is faster, the blue one, because the slope is higher. They're making greater change in a short amount of time. Steeper, yes. How many hours elapsed before the 2 cars were in the same location? So at 1 hour, they were in the same location. So I would say 1 hour. Or the same distance rather, from Leander. At that time, how far north are they from Leander? At that time, they're 80 miles north of Leander. Okay. During what time interval is car G further from Leander? So car G is like 40 miles from Leander, while car A is just 20 miles, so it's further away, G. And then they get in the same spot after 1 hour. So I would say between 0 and 1 hours, card G is actually further away. So between 0 and 1. Sorry, notice that it's a hard bracket at 0 because they're for sure. This one is for sure away from it, but we can't include 1 because they're in the same exact spot. So 1 is not included. Okay. Example 10, last one, I think. In 2003, consumers used credit and debit cards to pay for 41% of all purchases. I know we probably like 90% of our purchases are now use credit and debit cards. Nobody really uses cash anymore. This percent was 61% in 2011. Of course, it's going up. Find the linear function that models this data. So we have 2 points. We can find the slope. Point 1, 41% in 2003. Point 2, 61% in 2001. Find the slope. Changing y over changing x. 61 minus 41 over 2011 minus 2003. That's 20% increase in 8 years, which is about a 2.5% increase each year. Then use the point slope formula to write the equation. So we got our points, we have our slope. Put the slope of 2.5% change every year, the year 2003 for x and the 41% for y, and we're going to solve this distributive property and combining like terms. So this is our equation with our slope and our y-intercept. Okay. So that is a linear equation. Y'all, we've done this same type of problem 6 times already. You know this is going to be on the test. Taking 2 points from a situation and being able to write the equation of a line. In 2003, same situation. Estimate what percentage, when the percentage was between 46 and 56%. So we know it was sometime between 2003, which was 41, and 2011, which was 61. But we want to know specifically 46 and 56. So what years were that? Okay. So from part A, we bring in this equation. And we need to solve for 46 and solve for 56. So we say, when was this equation between 46 and 56? That is when this inequality can be used. So you take that whole equation and you plug it in between 46 and 56 and you solve for x. X is going to tell us the amount of years. Add the y-intercept, 4,966.5. And then we're going to divide by 2.5. So between 2005 and 2009 was when it was between 46 and 56%. How you put that in the interpretation is from about 2005 to 2009, 46 to 56% of consumers use credit or debit cards for all of their purchases. And we are done. Thanks so much. Watch the video again if you need any help, and we will discuss this in class the next time I see you.